Hello everyone, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you have not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. So problem is k different pairs in an array. Very easy problem. We are given an array of integers and a number k. We need to return all the unique k different pairs in the array. So what does that mean? K different pair is an integer pair nums I comma nums j where the following are true. I and j is less than nums length and nums of I minus nums of j should be equal to k. Right. So that means if you subtract nums j minus nums of I, if you do that, or like the difference between both these numbers, there should be two numbers and the difference between them should be equal to k. So let's see this test case. So here what we are given is we are given this array and we are given k. So k is 2. Means we need to find two numbers, that is we need to find two numbers ARR of I and ARR of j, right, such that when we subtract them we get what? K. We get k. So this is absolute. This is absolute. Means like the overall difference should be absolute value of the difference should be k. So if you see what all pairs are there in this array, whose like if you subtract them it gives 2. So see 3 and 1 is there, 3 and 1, 3 minus 1 will be 2, so this is one pair, and 5 and 3, so you can say 3 and 5, 3 and 5. So if you subtract 5 minus 3, if you do that you will get 2. So these two are the pairs. So answer will be what? Answer will be 2 because there are two pairs. So we have to return the count of how many pairs are there. So output will be 2. Right. So I hope you understood this thing. Now let's see how we can approach it. So here what we will be doing is we will be seeing two approaches. First we will see the better approach, and then we will be seeing the like first we'll see brute force, then better, and then optimal. See guys, we have to find pairs now. We have to find pairs. So whenever we have to find pairs, the simple brute force approach which comes into mind is that we have two nested loops. The same like thing na? We have two nested loops and we will consider all the pairs. This is the I loop, this is j loop. ARR of I minus ARR of j, absolute value of this should be equal to k. If this is the absolute value, if this is so, then just increment the count plus plus. So using this approach, you will be considering all the pairs which can be possible in this array. That is 3 with 1, 3 with 4, 3 with 1, 3 with 5, then 1 with 4, 1 with 1, then 1 with 5, 4 with 1, 4 with 5, and 1 with 5. So all the pairs you will be considering, all pairs. So obviously time complexity for this will be O of n square, which is not efficient, right? So there is extra loop which is this one, this j loop, and we can avoid using this. Right now this j loop is taking n complexity, na? It's taking n, O of n. It will run, so it is taking O of n. What we can think is we can think of reducing this O of n to O of log n. So if this O of n is reduced to O of log n, this time complexity of this will be what? Outer loop is O of n and inner loop is log n, so it will be n log n. If somehow we can reduce O of n to O of log n. Now log n is what? Log n is what? When log n time complexity comes? When we use binary search, right? Binary search has what? Log n complexity, na? So what we can do, see, what we can do is we can use binary search. We will be doing what? See, we will be going to each element and we will be finding in the rest of the array So see, we are currently at 3. So in this rest of the array na, first of all what we have to do is see binary search, always the array should be sorted na. So we will be sorting this array first. First condition of binary search is array should be sorted. So we are sorting. So 1, 1, 3, 4, 5. This will be the sorted array. Right? Then what we can do is simply, we are currently here. We just need to find what? We need to find whether there is 1 plus k. Because see, ARR of j minus ARR of I we need to find na, if it is equal to k. So we are fixing, we are going to each element and that is our ARR of I. And we are finding j. ARR of j will be what? ARR of I plus k na. So this is all our ARR of i's. And we are finding ARR of j. So ARR of I is what? 1 plus k. K is 2. So 1 plus 2 is 3. So what we will do, we will find 3, whether 3 is present in this array or not. 3 is present. So we got a pair. We got a pair. So you will go ahead then. So you will not consider this 1 again, because then it will give the same pair. We have to take only the unique pairs. Only unique pairs. So you will just shift I until the values are same. So these i's are same, now just shift it. Now from here you will check. So 3 plus what? 3 plus k. K is what? 2. So 5. You need to search 5. So 5 is there here. 5 is here na? So we got another pair. So pair, another pairs. So in this way you can use binary search. For each element you are searching, it's this ARR 5 plus k in the rest of the array. So this is one approach, right? And this time complexity will be n log n. N log n. Right? There is one more approach, which is again n log n1 only. So let's see that. 3, 1. We have array as 3, 1, 4, 1, 5. Right? We have this array 3, 1, 4, 1, 5 and k is 2. So see, whenever you have to find pairs, if you remember, we have discussed that in sum question, that if we have to find pairs, so what we can do is we can use 2-pointer approach. 2-pointer. Why 2-pointer? Because see, we have to find pairs now, means we have to find 2 elements. So 2-pointer, 1 pointer will be pointing to the first element and second pointer will be at the second element. So whenever you have to find pairs, you can use 2-pointer approach. So how we will use that over here? See, we will be taking 2 pointers. Pointers, they are not really pointers, they are variables only that will be storing indexes. So just do indexing. So currently we will be taking I at 0 and we will be taking j at index 1. But before starting 2-pointer, we have to again sort the array, because for 2-pointer we have to sort the array. Sorry, so we will sort the array. So this will be 1, 1, 3, 1, 5. Oh, sorry, my bad. Just a second. Here what will be the array? So I will change here only. So now the array will be what? 1, 1, 3, 4, 5. This will be the new array. 1, 1, 3, 4, 5. Sorted array. Right? So now I is here at 0 index and j is here. So what we need to find? We need to find out whether ARR of j minus ARR of I is equal to k or not. We need to find this thing. Na? See, over here, ARR of j is what? 1 minus ARR of I is what? 1. 1 minus 1 is what? 0. But what? Difference is coming out to be 0. But what we want the difference? We want it to be 2 na? We want it to be 2. So this difference is less than expected. This difference is less than expected. So if we have to increase this difference, what we have to increase? ARR of j or ARR of I? Think about it. This difference is less than the expected one. So if we have to increase this difference, what element we have to increase? This one or this one? So we have to increase this one, na, ARR of j, so that this increases and then the difference comes more. Because let's say if this is 4, then 4 minus 1 will be 3. So we have to increase j. So if difference, see, if the difference, this is the difference, if difference is coming out to be less than k, means we will increment j plus plus. We will do j plus plus. This is one condition. So j, move it ahead. Right. Now again check. Again check ARR of j minus ARR of k. ARR of j is what? 3. Minus ARR of I is what? 1. So 3 minus 1 is 2. Now this is equal to the expected k. So this is one pair. We got 3 comma 1. 3 comma 1 is one pair. So you can increment your count. Count becomes 1. Right. Now see. We will shift I ahead, because see, this 1 and 3 can also be a pair, na? So just shift I. J will also be shifted, and also shift I. So I come here. So I will come here. Now see, like when we got the difference is equal to k, we shifted both I and j. Alright, now 4. ARR of j is what? Again do it. ARR of j is what? 4 minus ARR of I. ARR of I is what? 1. Which is 3. So 3. Now see, this difference is greater than the expected. Expected we want 2, but now difference is 3. We need to decrease this difference. So what we will do? We will increase ARR of I, because if ARR I is 2, see, then this difference is 2 now. So what we will do is, we will, if over here now, another condition will be that if this difference is greater than k, then we need to increment I. Right, so I will come here at 3. Now again, ARR of j is what? ARR of j is what? 4. So 4 minus 3. 4 minus 3 is what? 1. So 1, this difference is less than k. So if difference is less than k, j plus plus. J will come here. Now again, see. What we will do is 5 minus ARR of I. What is ARR of I? ARR of I is what? 3. So 5 minus 3 is 2. Now again we got k. So we got k. So we will increment j and I, and we will also increment our count. Count will become 2. Now j is out of bound, means we got all the pairs. So now we will stop. So see, this is one approach, 2 pointer. We sorted the array and we are just shifting the pointers based on this difference. Right, so I hope you got the approach. Code is here. So just quickly we'll go through the code. So we have taken these pointers, sorted the array first. And then what we are doing is, if the difference is same, like if we got the difference, increment I, j and answer, and just increment, just move j ahead so that we do not get the duplicate elements. Duplicate also we have to avoid, na? So we are doing this so that we do not get duplicate pairs. And then if the difference is greater than k, so if the difference was greater than k, then we were incrementing I. And if the difference is less than, so we are incrementing j. So if you submit this, this is getting accepted. Right, so see, we are doing sorting here, na? So this is also O of n log n, time complexity. Space is O of 1. There is no extra space we are using. Now the optimized approach which we can use for this problem is wherein our time complexity will be O of n, but we'll be compromising on space. So we'll be using some extra space. So let's see what it is. So we have this, na, 3, 1, 4, 1, 5. 3, 1, 4, 1, 5 we have. And what is k? K is what? 2. See, earlier what we were doing? If you remember the binary search approach, right? We fix this ARR of I. We fix this ARR of I and ARR of I plus k. ARR of I plus k, which is our ARR of j, we are searching in this rest of the array, na? So that searching was log of n. What we can do to avoid this searching is that, can we use a data structure where searching time is constant? If this searching time becomes constant, then O of n log n, where this log n was for searching, if this is constant now, so O of n will be the time complexity. So whenever you have to search an element in constant time, then you can use hash map. You can use hash map for that. So what we will do, see, what we will do is, we will use a hash map. We will have a hash map. Let's create this hash map. Right, we are creating this hash map. And we are just adding all these elements in the hash map. So this will be the element and this will be the count of that element. Count of that element. So first we have 3. 3's count is 1. 1 is there. How many times 1 is there? 1 is 2 times, so its count will be 2 times. And then 4, it's 1 time only, and 5 we have, which is also 1 time. So this is the hash map we created. Now it's very simple, guys. What we will do? We will go through the array. So this is ARR of I now. We will be finding whether ARR of j is in the hash map or not. If it is in the hash map, we found a pair. ARR of I was what? 3. So 3 plus k, which is 2. So 5. 5 is in the hash map? Yes, it's there na. So we got a pair, 3, 5. So count will be 1. Go, move ahead. So here, now ARR of I is what? 1. So 1 plus k. K is what? 2. 3. 1 plus 2 is what? 3. So is 3 present in the hash map? Yes, 3 is present. 3 is present na. So we got another pair. So count 2. Basically, you know what, like, now you will understand something. Now we go here. 4. So 4 plus, we do 4 plus k. K is what? 2. So 6. 6 is not there in the hash map. So we will go ahead. Now see again, guys. See again. You come again to 1. We are again coming to 1. So we will do 1 plus 2. We will get 3. And we will search it in the hash map. We will try to search it in the hash map. But we will find it. So we will increment the count again. But earlier we have taken this 3, 1 combination. Now we have taken 1, 3 combination. So we will not iterate on this array. We will be iterating on this keys of the map. We will be iterating on the keys of the map, so that we do not have duplicate pairs, because 1 1 was occurring 2 times na. So 1 with 3 also, and again 1 with 3. We have to have unique pairs. If you remember, unique pairs we have to return. So that's why we'll be iterating on these keys of the map, and accordingly find the output. We will find the output. So here, when we are here at 5, so we will do what? 5 plus 2 is what? 7. 7 is not in the hash map, so just go ahead. So we found 2 pairs, 1, 3 and 3, 5. Right? So I hope you understood this approach. There is one edge case in that. Let's see that. So we have what? We have again 3, 1, 4, 1, 5, and k is equal to what? 2. So let's do one thing. Let's take here, in place of 5, let's take 3. So now for this and also here, let's take k as 0. Let's take k as 0. Right. So k is 0. So see, what we will do is, first of all, we'll make a hash map. So hash map will be taking, this is the element and this is the count. So 3's count is what? 2. There are 2 times 3 occurring. Then 1 count is what? 2 again. And 4 is what? Only 1 time. This is the hash map. Now what will be the output? So k is 0. Means we have to have ARR of j minus ARR of I, and that should be equal to what? 0. Difference should be 0. Means when is difference 0? Difference is 0 when there are elements are same. Both the elements are same. So 3, 3. This here difference will be 0, right? So what will be the, how many pairs are like that? We have 3, 3. We have 1, 1. We cannot take 4, 4. because 4 is only occurring once. So we cannot take 2 times 4. That's not possible. So pair can be taken only if for a certain number there are more than one occurrence. More than one occurrence, then only its pair can be taken. I hope you understood this point. So let's see now what we have to do here. So see, now what we will do is, when we iterate through these keys, so we'll go to 3. Now we will check whether k is 0. K is 0 na. So what we will do, we will just simply check if we have, this is a count of 3 na. So if count of 3 is more than 1, so we can take a pair of this 3 with itself, right, like that. So we will increment our count 1. Then again we'll go here, we will see k is 0, and for this 1, its count is, there are 2 ones, so we can take its pair 1 comma 1. So count will increment and will become 2. Then we go here, we see k is equal to 0. So how many times 4 is occurring? 4 is only occurring 1 time, so we cannot take its pair. So only 2 pairs are there. So I hope you understood this test case also. Let's see the code now. Let's see the code for this. So here what we are doing is just this simple, like if k is negative, just return 0. And we are taking this map and we are storing the element along with its count. And then we are taking this count variable, which we will return that how many pairs are there. And then we are going to each element, each key in the map. This is map. We are not going in the array because then the duplicate pairs will be taken. We'll be going in the maps keys. And if k is equal to 0 and its second, p dot second means this value. If this value is greater than 1, right? Otherwise, if we have k as some number like 2, 3 and it's p dot first plus k, that is like we were finding the 3 plus 2, 5. So if 5 is present in the map, so that if that is there, so increment count. And lastly, return count. So here see, we are taking, just going through the keys, so its time complexity will be O of n, and we are storing the keys, so it will be, space will be O of n. I hope you understood all the approaches, and let me know if you have any doubts in the comment section. And if you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video.